For a long time, if you heard the words heat pump, you probably pictured a machine meant for places where winter means a light sweater. If you live somewhere with actual blizzards and freezing temperatures, the logic was you needed a massive, heavy metal box in your basement, burning natural gas or oil to keep the pipes from freezing. But the engineering has shifted. Today, systems exist that can sit right in the middle of a winter storm and provide steady warmth inside. These are cold climate heat pumps, a specific class of equipment designed to handle the demands of extreme northern weather. The question people often ask is how a machine can find heat to move into your house when the air outside feels like a freezer. It comes down to a simple reality of physics. Even when the air feels freezing to your skin, there is still heat energy bouncing around out there. It exists in the atmosphere all the way down to absolute zero. Think of it like a slightly damp kitchen sponge resting on your counter. It doesn't look like there is much water in it, but if you apply enough pressure with a mechanical press, you can still force out a drop of water. A heat pump does the same thing with temperature. It acts as a collector, gathering those scattered heat particles from the freezing winter air and concentrating them into a steady stream of warmth for your home. Instead of creating heat by setting fuel on fire, it acts as a mechanical sponge, gathering the ambient heat that is already outside and bringing it indoors. To see why moving heat is more efficient than creating it, we can look at an older technology, like a standard electric baseboard heater. These heaters operate on a strictly one-to-one trade. You pay for 1 unit of electricity, and the heater creates exactly 1 unit of heat. This chart shows the efficiency multiplier, the heat we get for the power used. With a standard heater, 1 energy unit goes in, 1 comes out. A heat pump moves heat, offering a higher return. 1 electricity unit gathers 3 heat units. This efficiency multiplier is the reason why these systems can lower monthly energy bills compared to traditional heating. Earlier versions of this technology did have a limitation. As the temperature dropped below freezing, the system lost its ability to gather heat effectively. Modern units solve this with a feature called vapor injection. It acts like a turbocharger, pushing the system to maintain its full heating power, even when the temperature drops to 5 degrees Fahrenheit. If you live in a place that faces extreme deep freezes, you might still want an extra layer of reliability during a heavy winter storm. For those scenarios, you can install a hybrid system. This pairs the electric heat pump with a backup gas furnace that stays off most of the time, only turning on during those rare, brutal cold snaps. Whether you choose a purely electric setup or a hybrid system with a backup furnace, you have a reliable way to keep your home warm. Even advanced technology can fail if it is installed poorly. One of the most common mistakes is installing an unnecessarily large unit just to be safe. An oversized machine will heat your house too quickly, shut off, and then turn right back on. This constant cycling wears out the compressor and reduces the system's efficiency. To prevent this, ask for a mathematical load calculation, often called a manual J report. This ensures the machine is sized exactly to the needs of your specific home. The physical placement of the outdoor unit also matters. It should be elevated 18 to 24 inches on a specialized snow stand so it doesn't get buried in drifts or crushed by snow sliding off the roof. The system can only do its job through the winter if it is installed with this level of physical and mathematical precision. There is one last technical detail to check: the wiring. High-performance heat pumps need specialized 4-wire shielded cables. If an electrician uses standard doorbell wire, the thermostat and the pump won't be able to communicate properly. When you're looking at a specific model, there is a tool you can use to verify its performance. Ask your builder if the unit is listed in the NEEP database. This is an independent database that provides rigorous testing data, proving exactly how much heat a machine can provide when the weather is at its coldest. Keeping a home warm today involves using tools that work with the physics of the environment, rather than simply trying to overpower the cold. If this guide helped you understand how to plan for a colder climate, please like the video and subscribe to the channel for more ways to build a smarter home.